One of the most important application or benefit from Thevenin equivalent circuit is to find out the maximum power transfer. Assume that we have this circuit here, for example. So we have this circuit. This is Thevenin equivalent circuit. The voltage is 2.1 volt. The Thevenin resistance is 6.8. And I want to find which load here, which RL, that will give me maximum power transfer, will produce the maximum power transfer from the source to the load. Okay, so for example, let us see if we have this RL is a variable like what we have here, 2.2, 3.3 until 14.7, and we need to calculate the power in this load. How we calculate the power? Of course, it is voltage time current, or you can say I square, this I, or I call it IL, time RL. IL square, this I, current, square, time RL. So first I need to calculate the current, and this is how you calculate the current. The current equal what? Equals this 2.1 or V7 divided by the total resistance, which is 6.8 or R7 plus RL. So this is how you calculate the current. And once you calculate the current, square it and multiply it by RL. This will give you the power in the load. So let's calculate it for one resistor, for example. Now let us see if we have 2.2 like this. It is 2.2. Then what's IL? IL is V7, which is 2.1 volt, divided by, between brackets, 6.8 plus RL, which is 2.2. 2.2 closed. Okay, so this equal what? Equal 0.233. So it is 0.233. So this is what I need to write here. 0.233 whatever ampere. 333 ampere. And then if you want to calculate the power, so what you need to do is to square IL. So you square it. Here it is. And then multiply it by RL, which is 2.2. So this will give you 0.11977. 0.11977. Of course, the power is in watts. Let's repeat this again for another resistor like 3.3. How do I calculate 3.3? Okay, so the current is V7, which is 2.1 volt, divided by RL is 3.3. Oh, sorry, I have to add a bracket first. 3.3 plus the resistance, which is 6 R7, which is 6.8. Close it. Okay, and then equal 0.2079. 0.2079 ampere. And then you calculate the power. How you calculate the power? You need to square it. You see, square this IL, so square, and then multiply it by RL again, 3.3. This will give you 0.14266. 0.14266. So it's 266 watt. Okay, as you see here, the power is increasing. The power was 0.119, now it is 0.14. Okay, and so on. And you repeat this. Of course, if you want to do it in an easy way, you have to use Excel. So how, for example, let's see, let us do it here. Make it clear. So here is the resistance, RL is 2.2 and so on. So these are the same numbers, like this one here. So this IL equal what? We need to write equation here, so we have to write equal what? Equal V7, which is 2.1 volt, divided by, open bracket, and this RL is this field here, so you have to click here, plus R7, which is 6.8, and you close it, and then you hit enter. So this will be the current. And then what is PL? PL equal, have to write equal sign, equal IL square. Then this one here square, you can write square IL time IL, or you can just hit this symbol and square. So this is IL square, P2 square, time what? Time RL. RL is this one here. You click this, and then you hit enter. So now this is the power. So as you see, I believe that this is the same numbers that we have here, 0.233, 0.197, and so on, 0.1197. And then after that, you select these two cells and then copy them to the rest. So you make it like this. You know how to copy? You just click. When you click, you have to look at this dot, this one here, the edge, and then move it like this. That's it. So now you copy the equations. So this will give you all the values. All the values. If you look at, for example, 3.3, give us, I believe, the same number, 0.2079 and 0.14266, and so on. Okay. So now let us look at the values of the power. Which one is the maximum here? Which one is the maximum? You see here it is increasing, and then here, and this is the value that has the maximum number, 0.162. This is the maximum power. So let us make it here in green, for example. This is the maximum power. So the maximum power happen when RL equal what? Equal 6.8. Okay, so what's 6.8? 6.8 is simply the R7. So this one here, when RL, can say RL equal R7. That's it. Okay. So maximum power happen when RL equal R7. This is the condition for maximum power transfer. And then how do you calculate it? You just calculate the current and square it and multiply by RL. Okay. If you want to check how it look like, you can plot this. You can go, for example, here. Let us maximize this, and then go to insert, and then you plot, for example, this one here. This, of course, will plot IL and RL. So these two curves, IL and RL and PL, I don't need IL. So I have to, for example, delete, let's see here, the properties, or delete this one here. I don't need IL. IL is a blue, so delete this one here. Okay. And then you can change the scale here because it doesn't look nice here. So you don't need it from 0, because it seems that the minimum here is 0.12. So 0.12 is the minimum. Okay. Then as you see here, this is the maximum happen at this point here. If you click this point, if you go to this point is 6.8. 6.8. So it happened, the maximum happened at 6.8 when RL equal R7. Okay. So when we finish this means that if we want to choose a resistor that has a maximum power transfer, this RL must be equal to R7. Very simple. So the condition is very simple. And the value for the maximum power is very easy, as you can calculate like this. You can calculate like this, or you can calculate as you like. Just R7 and equal RL, and then calculate the power in this resistor. So this is simply what we call it here, maximum power transfer theory.